Hello, and welcome to Calculus Lesson 124. Today we're going to do implicit differentiation, part 2. So let's go over what implicit differentiation is already. I think they used 100 here. So implicit differentiation is when instead of solving for y, we just take the derivative willy-nilly, right? So here, we're going to take the derivative with respect to x because there's an x there. So it'll be 2x dx. Here, we're going to take the derivative with respect to y because there's a y there. So it would make sense to take the derivative with respect to x. So I'm going to take the derivative with respect to y. The derivative of a constant is 0. Then you solve for dy by dx. Simple as that, right? Well, much like our previous few lessons, calculus just gets more and more complicated. What happens when I want to take the second derivative of that, or d squared x by dy squared? That's wrong. Yx. There we go. Well, here's the deal. I'm going to take the derivative with respect to x of negative x over y. Since this is a quotient, I'll have to use the quotient rule. So what's the derivative with respect of x of negative x? That's negative 1 times the derivative of the bottom minus the derivative of the bottom. Now here's where it gets tricky. What's the derivative of y with respect to x? Well, that's dy by dx. Okay, here when we took the derivative of x, it was 1 or negative 1 dx. So the dx's cancel, if I may. And there's no dx here. But when I take the derivative with respect to x of y, I get dy by dx. That's what we've been doing this whole time, right? You have y equals something, you take the derivative, you get dy by dx. So when I took the derivative of y here, I got dy by dx times the derivative of the unchanged top, which is negative x. That's all over y squared. So notice the added complication here. It's really important that you catch those dy by dx's. Anytime you're taking a second, third, fourth, fifth derivative, and you take the derivative of y with respect to x, you have dy by dx. Okay? And so we're going to have to plug in our original dy by dx. So I have negative y plus x times negative x over y. There we go. Over y squared. Now I can simplify this a little bit. If I add these two fractions, then I have negative y squared minus x squared over y cubed. I can bring out the minus sign so these become positive. And that is it. Cool. So they could also ask you to find the derivative at a particular point. Or you could actually represent this in a different way. You remember that the original equation was x squared plus y squared equals 100. So in fact, you can make that substitution since we have x squared plus y squared on top. And it's just simply negative 100 over y cubed. Gross, I know, but you have to be able to change with these different forms. You might think you have the answer. You might think here that you have the answer. You might think here you have the answer. You have to be able to match what they're looking for, especially when we're talking about multiple choice problems. Let's try another one. So we're going to find the second derivative of 4y squared equals x cubed. So in order to find the second derivative, I must find the first. So this is going to be 8y dy equals 3x squared dx. So I'm going to solve for dy by dx, which is 3x squared over 8y. Now to find the second derivative, I'm going to take d by dx of that. So how do I do that? Well, derivative of the top is going to be 6x times unchanged bottom minus the derivative of the bottom, which is 8 dy by dx. Remember, when I take the derivative of x, that drops a dx. I have dx over dx, no big deal, they cancel. Here, when I take the derivative of y, I get a dy by dx, and so those don't go away, times unchanged top. That's the quotient rule, divided by the bottom squared. Okay, from there, I know that dy by dx is that, so I'm going to plug that in. I have 6x, or 6 times 8 is 48. xy minus 24 x squared times 3x squared over 8y all over 64y squared. I can do a little bit of simplification there. Flipping page. And I get something ugly like 48. Sorry for going so low. Wow. There we go. 48 xy squared. Right, I'm gonna want a y in the denominator, so I'll have to do that both. Minus, it looks like 24 and 8 cancel, 8, 16, 24 minus 9x to the 4th over 64y cubed. Wow, that's gross. But guess what? They simplified it further. How can we simplify this further? Well, if you're stuck on a multiple choice question on the AP exam and they give you a bunch of answers and it doesn't match this one, it's because you have more work yet to do. So let's do that more work now. We'll jump back up here. Remember that our original equation was 4y squared equals x cubed. So I want to simplify this down as much as possible. I have a 4y squared here, so I could simplify that. Is that what they did? Yes, they did. So this is 12x times 4y squared. And here we have a, let's go with a 9x times x cubed over, there's a minus sign in there, 64y cubed. What I'm trying to do is I'm trying to get some of these big numbers to cancel. I could also factor out of the top. It looks like these have 3 in common, but 3 doesn't go into 64 anyway. So let's see what we get here. X cubed is 4y squared. So I'll replace that lazily by erasing. And 4y squared is x cubed. So now I have, why did I do that? Yeah, it works. Okay, so I think I did too many substitutions. So let's leave this one as x cubed. So I have a whole lot of x up here, right? It looks like I have x to the 4th minus x to the 4th, right? So 12 minus 9 is 3. And that looks pretty simple. Now let's see what I can cancel, because I see that I have x's on top, but I have y's on the bottom. So x to the 4th is x times x cubed, which is 4y squared. So I can cancel some of these. I know I'm going down a slippery slope here. I apologize. 64 divided by 4 is 16. Y cubed divided by y squared is simply y. And so your answer, even though you had all of this ugliness, is 3x over 16y. And that's the second derivative. So this is not easy. You guys can do it. You've got this. And that, my friends, is problem set 124.